Good morning to all. I'm Saranya Devi. I'm working as an assistant professor in ABS College of Technology. So today we are going to see the subject about VLSI and chip design, which comes under third year, fifth semester. So what is VLSI? VLSI is nothing but very large scale integration. In VLSI page, millions or billions of MOS transistors combined into a single chip. In this, the important transistor is considered as MOSFET. So in MOSFET, there are two types, that is PMOS transistor and NMOS transistor. Let us see the overview of MOSFET detailing. MOSFET transistor. MOSFET is expanded as metal oxide semiconductor field effect transistor. It's a semiconductor device which is widely used for switching and amplifying electronic signals in the electronic device. MOSFET is a four-terminal device which is source, gate. MOS transistor is called a majority carrier device. MOS transistors are electrons and PMOS transistors are holes. So in this diagram already, these are the symbols of NMOS and PMOS. In this, the drain and source. The arrow mark indicates the flow of current. Next, in this we are going to see two types, that is enhancement type and depletion type. What is enhancement type? If a MOSFET is off at zero gate source voltage and can be turned on by applying voltage at gate terminal, then MOSFET is known as an enhancement MOSFET. Depletion type MOSFET is nothing but if a MOSFET is on at zero gate source voltage and can be turned off by applying voltage at the gate terminal, then the MOSFET is known as the depletion MOSFET. So let us see the overview and detailed view of NMOS transistor. NMOS transistor is a majority carrier is electrons, and this is the symbol of NMOS transistor, that is source, gate and drain. So what are the functions of source? The source terminal serve as a source of carrier either electrons or holes. The drain terminal collects the carrier flow from the source terminal. So this is the structure of NMOS transistor. So in this, N plus is heavily doped, and we are here placed source and drain. It is a silicon conducting layer, silicon layer, which is a excellent current conducting material, and with the majority is holes and minority is electrons. In this, if we applied a high voltage in NMOS, it turns to on condition and it will be a closed switch. If we apply a low voltage and it turns to off condition and the switch is in open condition. So this is the overview functions of NMOS. Let us see the functions of PMOS transistor. PMOS transistor majority carrier is holes. So here N-type semiconductor is taken as a substrate. P plus P plus indicated heavily doped from the source and drain of transistor. PMOS has majority holes and minority electrons. N-type semiconductor which has majority electrons and minority holes. So in this already we explained in NMOS transistor, which is in if we give a low voltage, if we give a high voltage, it turns to on, and if we give a low voltage, it turns to off. It is opposite condition in PMOS transistor. In this, let us see, if we give a low voltage, the PMOS transistor tends to on and it is a closed switch. In this, if we apply a high voltage, then a PMOS transistor is an off condition and it tends to open switch. P plus indicator heavily doped from the source and drain of a transistor. The carrier flow from the source to drain terminal through a conducting path is called a channel. The carrier in the channel are now positive in this channel. So, what are the advantages of MOSFET and applications of MOSFET? It is a higher efficiency and low terminal requirements and reduced system cost. Effect of noise less than BJT. BJT is nothing but bipolar junction transistor. So, what are the applications of MOSFET? MOSFET are used as oscillators in radio system, used in calculators, used in radio switches. MOSFET are used in digital integrated circuits such as a microprocessor. Thank you.